to go.
All right, thank you. Hi, folks. Thank you for joining my presentation about Informix automatic space management. So I'm Mike Walker. I work for XDB Systems, where I run the remote DBA and remote monitoring services. So automatic space management was introduced in Informix in 11.7, and I didn't start looking at it for a little bit, thinking it was mostly intended for like autonomous systems or systems that ran without a DBA, just so Informix would take care of adding the space. That's until a few years ago, we started working with a customer with a very large system who added a ton of data every single day. And there we started using the automatic space management to extend spaces, and it just really simplified things because adding space manually was just becoming such a time-consuming job. So I want to share with you how to use the automatic space management and how it all works. I've got a lot to cover, so I'm just going to jump right in. Okay, so adding space, as DBAs, we're probably all very familiar with monitoring DBSpaces, the amount of free space we've got, how fast the DBSpaces are growing, and we'll take the steps to go ahead and add space when needed. We've probably got scripts out there that are running, and we'll get alerts like, hey, this DBSpace is below 10% free, and we'll go ahead and take action. So we're always like one step ahead. But there's always times when we need to quickly add a DBSpace or add a chunk. And the main thing we want to do is make sure our applications can continue to run smoothly and not run into problems because we're out of space. So what happens when DBSpaces fill? We've probably all seen these kind of errors before. The application is going to generate an error, could not insert a new row, got no free disk space, the DBSpace is full, and then we're going to have to jump into action and go ahead and create a chunk or expand a DBSpace. Now, we want to avoid that because obviously the applications, we just want everything to run smoothly. And automatic space management gives us the option to do that. It really does make life much easier. So there's two main parts to the space management, the extendable chunks, and this is where we can get Informix to stretch out cooked files. So it's only for if we're using cooked space, and it saves us having to add a chunk. Sometimes we can just take that the Unix file that underpins a chunk and we just stretch it out. It's an easy way to add space. The second part is to use a storage pool. This is where we allocate resources into a pool, and when we need to add a chunk or add a DBSpace, we simply pull the resources from that pool and go ahead and add that chunk. And the syntax is really easy. So if you need to do something quickly, it's really quite simple. You know, space has already been added or allocated, so you don't need to give it much thought. And for both of these, we can either do them manually, or we can just have Informix try and take care of everything and maintain a certain amount of free space. To use the space management feature, we do need to have SP auto expand set in the on config. It is a dynamic configuration parameter, so there's no restart needed. You just enable it with on mode -WF or WM. But it's normally set by default, so you may have turned it off, but if not, it'll be set to 1 already, and you can just go ahead and start using these features. So I'm going to start with the extendable chunks. So the clue is in the name. We're talking about extending chunks. Now, this is not at the DBSpace level. We have to specify which chunks we want to extend, but you'll find a lot of the configuration is all done at the DBSpace level. And I'll try and differentiate which is which. We can only do this for cooked files. So if you're using raw space, you can't use extendable chunks, but you will be able to use the storage pool that I'll come on to later. So as I said, we can use these extendable chunk feature to be able to grow a DB space by just stretching out that underlying Unix file. It can be automatic, or we can do it manually. So first thing to do is we need to mark our chunks that we want to be able to extend. And we do this together with many of the things that I'll be presenting today with the sysadmin API. And so we call execute function task. And then depending what we pass it, we can implement the different features. So here, we're just going to call that task with modify chunk extendable. And we pass it the chunk number that we want to extend. So similar routine to turn off the extendable feature for a particular chunk. We're just with this modify chunk extendable off. As soon as we mark a chunk as extendable, if you run onstat-d in the flags option to the left of the path name, you'll now see a flag E for extendable. Also, the sysmaster table syschunks, it's got a is extendable column, and that will now show that that chunk is extendable. So what happens when we marked an extendable chunk? Now, if that DB space fills, where before we got that the errors, DB space is full, cannot insert more rows, that chunk will automatically be extended. So it'll just stretch, and at the end of the day, the good thing is the application won't fail anymore. It'll just carry on inserting data. So in this example, I've got an extendable chunk. It was 5,000 pages prior to it filling, and it jumped from 5,000 pages to 7,500, increased by 2,500 pages. This is a 4K page size, so that matches the 10,000K that we'll see in the message in the Informix log. So all that happened automatically as soon as that space filled. Now, why 10,000K? It's not quite an arbitrary number. It's the default that any chunk will grow, and it's set in sysDBSpaces. When you create a new DB space, that is just the default of the extend size. And we can see that in the DBSpaces, sysDBSpaces record. Here we're looking at test DBS, and we see that this column extend size, and it's still set at the default value of 10,000. Now we can change that. If we think that's too small, for example, we can go ahead and bump that up. Obviously, we don't want to update the sysDBSpaces record directly. That's a bad thing. But again, we've got another admin API function. We'll see this function a few times. It's got a number of different parameters, but here we're going to call this task and send it modify space SP sizes, and we specify what we want the new extend size to be. So here in this example, I'm going ahead and changing this for the test DBS. We're going to set that extend size to 25,000K. So in this presentation, I've mixed up the different syntaxes. So here I'm just using K, but you can also specify meg and gig just by putting the MB or the GB in the line here. Okay, so now when this space extends, it will expand by 25,000K. Now, there's a variation on this. If we set that extend size to less than or equal to 100, what will happen now is when that when a DB space fills, and if that DB space has extendable chunks, the chunks will be extended enough that the size of the DB space now grows by the given percentage. It's not saying I want this much free space in this case. It's saying, okay, fill DB space grow by, in my example here, 20%. So here's an example. I've got a chunk. It's an extendable chunk, 17,750 pages. The DB space filled. It doesn't have to be this chunk that filled, just the DB space fills. And it went ahead and stretched it out by 14,200K, which works out to 20%. Now, you might see sizes greater than 20% depending on what caused it to increase. For example, if you created a table with a larger extent size, it might go ahead and stretch out that chunk to accommodate the new extent size. So what we've discussed here is what happens when we go ahead and fill a DB space, how the chunk will stretch to allow the application to continue. What we're more likely to want to do is add that space proactively. So we add space before it fills. And we can do that by setting SP threshold in the Informix config. Again, another dynamic value, so no outage required to set this. Default is 0, but if you set it between 1 and 50, Informix will attempt to keep all of our DB spaces with that much free space. Now here, it doesn't mean, unlike the extend value earlier for the DB space, here we're trying to say, okay, Informix, try and maintain this percentage of free space, like 20%, 30%, whatever you feel comfortable with. It applies to all the DB spaces that have extendable chunks. I'm assuming here the storage pool is empty. We'll cover this again later. If you don't want to use a percentage, give it a value of 1,000 or more. And what will happen then is we'll say, okay, Informix, instead of keeping a free percentage, keep this amount of free space in K. So if I set it to 5,000, saying, all right, try and maintain 5,000 K of free space in all my DB spaces. Now, if we do leave it set as 0, that's fine. We won't get any of the proactive adding or extending of spaces, but we'll still get the advantage of when a DB space fills, any extendable space will be stretched at that time. So if you've set SP threshold to have Informix maintain a certain amount of free space, but you still go ahead and fill a DB space because you're just adding rows really quickly or something, then the DB space will be extended and as normal by the amount that's defined in the DB space. So here's our 10,000. But then later on, when Informix attempts to review all those spaces and expand everything to meet our SP threshold, then it'll expand by what we have in SP threshold. Now, I said when Informix tries to reviews the space to see if it can expand any, that's all performed by this job. It's a built-in task, mon-low storage. It's in the PH task table. It runs on a schedule, and by default, it runs hourly. So every hour, it will wake up, review all the DB spaces, say, okay, do I need to stretch any out to meet our SP threshold? And this is the record itself in sysadmin in PH task, mon-low storage. And you can see here the frequency is set to run every hour. We see when it's going to run again, and we see it's enabled for every day of the week. And the task itself is enabled there. TK enable is true. And you can just go ahead if you do want to change the frequency that it runs and disable it or change the days of the week that it runs. You can just go ahead and update this record directly to get those to the schedule that you want. SP wait time is the other setting in the on config. It's like a timeout. When a space fills and a process just, is trying to insert rows, it's like a timeout. Like how long should the application wait before for that space to grow before it just gives up and says, okay, DB space is full. Okay, so if we're now having Informix stretching out chunks for us, which is all great and everything, but we may want to put a limit on it to make sure that DB space doesn't grow just too big. So introduced in Informix 1210 XC4 was another option on our modify space SP sizes. And here we're setting a maximum size of that DB space. So up until that point, the chunks can expand until it hits this maximum. Now, again, this is at the DB space level, and it doesn't limit the size of an individual chunk. So if you've got chunks on different file systems, for example, you can't just go ahead and say, all right, have this chunk go up to this size and this chunk go up to this other size. It's all at the DB space level. So how do you tell when a chunk is being extended? Well, unfortunately, if it extends successfully, which is what you hope for, there's no entry put into PH alert and the alarm program isn't called. However, there is a message in the Informix log looking similar to this. But you could also just keep an eye on the size of DBSpaces, and if that size increases, then you know it's probably been extended. Now, if there's a failure with extending that DB space, then you will get an entry in PH alert and alarm program will be triggered. So here's an example where DB space was stretched out until it hit the maximum size that we'd set. And then we get, in this case, it's a warning, and we'll get a message in the log, and here we're looking at the PH alert. So we've mentioned that this only works for cooked files, but you can use this to extend temporary spaces, but unfortunately you cannot use extendable spaces for mirrored chunks, blob spaces, or smart blob spaces. If you try to, you'll get this message that the storage provisioning failed, and it'll tell you why. You can use extendable spaces in a replicated environment for HDR and RSS. And the interesting thing here is when you kick off the extend, the secondary or the RSS server will process that stretching of the DB space or stretching of the file first. So you'll be sitting there going, okay, I've issued an extend, but my chunk is staying at the same size. What's happening is on your secondary, that file is being stretched out. You can see it just using ls, these are cooked files, and you'll just see the file getting bigger. When the extend is completed on the secondary or the RSS, then the operation will be performed on the primary. And once it's been finished on the primary, then the extend is considered complete and successful. So a few recommendations. One of them is you probably don't want to stick with that default 10,000K. Depending on the size of your DB space and how rapidly it's growing, or the data within it is growing, you may want to bump up the amount that it extends each time. Otherwise, you'll run into a situation like this where there's the same chunk and it just keeps trying to get it extended. It's successful, but it's only extending in little bits. Not totally sure what will happen to the file underneath, but I would assume it get kind of fragmented, just growing over time on the file system. That goes on for a while. It's probably not a great thing. So if you are using the SP threshold, as long as at the very least, set it to 0 and start using extendable chunks, because then you're most likely going to eliminate all those errors where you're running out of space. Somebody added a new table that's growing much faster for some reason. Unless you want that to fail in that kind of situation, just having extendable chunks and even if SP threshold is 0, you'll get rid of those errors, those out of space errors. And remember that the SP threshold is at the instance level. It's going to affect all of the DB spaces. So be careful what chunks you want to mark as extendable. And if you go through and just say, okay, I want every single chunk to be extendable because why wouldn't I? You may find that they're all growing quite quickly and a little bit out of control. And maybe for DB spaces that you don't want them expanding, they're static. Something we'll mention in a bit, another way to stop that. Now, the extend size is at the DB space level, not the chunk level, as I mentioned. And if you've got a case where you've got your SP threshold is bigger than the extend size, that will always win out over the extend size that you've marked for a DB space. And be careful if you're using set SP threshold less than 50, where you're essentially using a percentage, saying, okay, I need this DB space to grow by or maintain like 20% free or 10% free. If you've got a huge DB space, that percentage could be really quite big. So if you are using a percentage, you either want to exclude that very large DB spaces from this process, or set a maximum size so it just suddenly doesn't jump up in one big bump up to just this much larger space that's going to just take forever to grow into. Okay, so previously, when you're adding space, you normally go through this process, right? And you're like, okay, this DB space is growing this fast. I've got these chunks. I'm using these file systems. This file system's getting kind of full. So I'm going to add a chunk on this other file system where I've got a lot more free space. If you're now, instead of doing that, you're relying on the automatic extending of spaces, then unless you're keeping a close eye on your file systems, you're going to find that all of a sudden they fill. Now you're stuck with a file system's 100% used. Sysadmins would be like, what are you doing? We don't want to go over 90% used on any spaces or anything. You can't shrink these chunks to free up space. You obviously don't want to have to do a reorg. So you've really got to keep a close eye on how fast the file systems are filling now. So what happens when an extendable space cannot be extended, perhaps because the file system is full? The operation will fail, and a couple of things will happen. The extendable flag will be removed from that chunk, so it won't be allowed to grow anymore automatically, which is a good thing. But the other thing is the Informix will not know that that chunk, because it couldn't be extended, it'll still think it's the same size. Now, what happened in our example here for the space to fill, that chunk was just kind of stretched out as it was being extended. It filled the file system, but that file is still at the bigger size. So we stretched it out. It's bigger, but Informix still thinks it's the same size. So now we've got space that is being allocated by the file that underlies the chunk. Informix still thinks it's the same. So now we've got wasted space. So what to do in that situation is you can manually modify the chunk size. We can extend it, at which point it will just grow out to the size of the actual chunk. Now, because the space has already been allocated, because that file's been inflated to the new size, that's a really quick operation. So just to explain what I'm talking about here, we've got a case where I've got a chunk, it's a 1.9 terabytes, sitting on a file system that's been configured with a maximum file size of 2 terabytes. So when this chunk of 1.9 terabytes tries to grow, for example, for 200 gig, it quite happily, Informix will start stretching out that file. It's not aware of the 2 terabyte limit, so it'll just start stretching that file out. It's going to get to 2 terabytes. The operating system is going to be like, whoa, hold on. You can't grow anymore, and that operation will fail. At that time, a file on disk is now 2 terabytes, so the maximum. Informix goes, oh, nothing changed here. The operation failed. I'm still at 1.9 terabytes. So now you got 100 gig sitting there allocated on disk, but will never be used by Informix. So when that happens, you go ahead, you stretch out the size of that chunk by 100 gig. Now Informix can use the entire 2 terabytes. Now, I had this situation. We had this 2 terabyte file size limit. We had a bunch of chunks, and many of the operations had failed to extend. And because they're big files, they were trying to expand by quite a lot at a time. It wasn't like we were just left with a few gig here and there. So I went through and compared the size of the actual files on disk with the size of each chunk that Informix thought it was, and worked out the delta, and then went ahead and ran a script to expand all our spaces or our chunks into the actual size of the file on disk. Doing that, I was able to reclaim a lot of space. Well, not reclaim it, but it had already been allocated, but now allow Informix to use it. There are times when other times when a chunk cannot be extended. One of those is if an archive is running. Now, if you're not adding space proactively and keeping that buffer of however many percent or however many K, you'll be in the situation where an application is running out of space, it tries to add more space, and now it tries to add more space, but an archive is running. And especially if that archive is one of those that takes a day or more to run, then you may not be able to add space or extend that chunk until that archive is over, and that might take a while. So even if you don't or choose not to use the extendable spaces or anything running automatically, you can still use this feature if you're using cooked files by temporarily extending a chunk. So I do this a lot. If we're getting low on space in a DBSpace, and we're using cooked files, I want to just stretch it out without having to add a new chunk. On these big databases, you can end up with a zillion chunks because each time you need to expand, you're adding a chunk. But here, we can just mark a chunk as extendable. We modify that chunk and extend it out, in this example, by 2 meg. When that operation is done, we just turn off the extendable flag. And we've just managed to add space, or in this case 2 meg, to our DBSpace without having to add a new chunk. And the syntax is so simple. It's easier and less error prone than trying to create a new cooked file and go ahead and run the on spaces to add it to the DBSpace. Okay, so that was all extendable chunks, expanding things by stretching them out. The other part of the automatic space management is to use a storage pool. So this is not now limited just to cooked files, but using a storage pool makes it a lot easier to go ahead, you prep all your files for your chunks or your logical volumes or whatever, and you add those resources to a storage pool. Now, if you need to add a chunk or create a DBSpace, you can do that very easily with real simple syntax and quickly add that space. We can also have Informix go ahead and use the resources in the storage pool for automatically making DBSpaces larger. So what goes in the storage pool? It can be a set of cooked files, set of raw devices, or even directories. So how do we add stuff to the storage pool? It's really simple. Again, we're using our sysadmin API, and we're using storage pool add. We pass it a few things, including the path name of our resource, the offset, the minimum size, how big we want any chunks allocated from that resource to be, or a minimum size, and a priority. So here's an example. We're adding a single file to the storage pool. It says chunk file 1. That file must exist already, and the permissions must be set, just like any other cooked file in this example. And we're specifying a fixed size. We're saying, all right, this file is going to be 10 meg. And from this, if you allocate any chunks, they must be at least 2000K. And it's a priority 1. We can have multiple priority 1s or 2s or 3s. So as soon as I add that entry to the storage pool, Informix will automatically go ahead and inflate that file to the size that I've specified, in this case 10 meg. So now it's sitting there and it's just ready to be used. Okay, but it hadn't been added to the database yet. It's just just a resource pre-allocated and ready. Once we add something to the storage pool, it'll appear in this storage pool table in the sysadmin database. So here's some information on that chunk we just added. Sorry, I'm calling it chunk. It's a file. It's not a chunk yet, but it is a file. It's a resource to be used for chunks. So if we do want to create a chunk though, and we want to create it from that storage pool, syntax is super simple. Here's our admin API again, create chunk from storage pool. We just need to give it two things. We give it the DB space we want to attach that new chunk to, and the size of the chunk. So here it's 1500K. So as soon as we run this, Informix will go ahead, it'll go to the storage pool. We haven't told it what entry to use from the storage pool. That will all happen automatically. But Informix will then go ahead, go, oh, I got a resource here, I got this file, it's big enough. And it will go ahead, allocate a new chunk using that file or from that file. Now, I said, let's create this of 1500K. However, Informix adds it for a 2000K. The reason for that is when we added the entry to the storage pool, we gave it a minimum size. So even though we asked 1500, it gave us something of 2000K. So because this entry in the storage pool had a fixed size, remember the 10 meg, any chunks allocated from it, they will not be marked as extendable. And that maximum size, the 10 meg, it's enforced. So anything we create from it cannot exceed 10 meg. Now, if we go ahead and now start allocating more chunks and there's room in that storage pool entry, we'll get more chunks added using that same file. But now what we'll see is we'll start getting offsets. So here we've got the same file used for two different chunks, but they're separated by this offset of 500. I don't know about you, for cook files especially, I hate to see offsets. It just gets a big old mess. So I'm not too keen on doing things without the extendable spaces. I like to tie one file to one chunk. It's just much simpler that way. Logical volumes, I see that more using offsets, but again, it can really get confusing. So how big are the chunks added from the storage pool? There's a few things that go into this. So the minimum size, just period, is 1000K for any chunk that's added. There's a minimum size that's defined in the storage pool. And here's something I struggle with, is that there's a, in the modify space SP sizes that we've used a few times already, there's a minimum size there for the DBSpace. It's a create size. I thought that would govern how big the size of a new chunk would be. It didn't work when I tried it using using the storage pool. Now maybe I'm just misinterpreting the results. I don't know, or the instructions there. Okay, so carrying on with adding entries to the storage pool. In that last example, I said, okay, the maximum file size here is 10 meg, and that'll be enforced. I can also add an entry to the storage pool and not give it a size. So here I'm saying the size is 0, but I'm saying the minimum size of any chunk created from chunk file 2, this entry here, must be at least 5 meg in size. Now, as soon as I add this entry to the storage pool, the underlying file will be expanded. It will be inflated to the minimum size of any chunk that is assigned from here, because we at least know that anything coming from this file must be at least 5 meg. So Informix will go ahead and stretch out that file to 5 meg. Now, when we do add a chunk from this resource, it will be added with the extendable flag. So now what we've got is this new chunk, it's extendable, and the storage pool entry would be now marked as full. That's saying, all right, this storage pool entry cannot be used for any more chunks. But if we do choose to extend this particular chunk, then the storage pool entry will be updated with new sizes. And now we've got a way to tie one entry in storage pool to a single chunk. So earlier on, when we talk about extendable chunks to grow your DB space, when we were trying to extend our DB space, we were saying, okay, take this chunk and make it this much bigger. There's an easier syntax we can use, which is this modify space expand. And all we need to do is supply it the DB space name and how much bigger we want this DB space. Informix will say, okay, you want this DB space bigger. Are there any extendable spaces? If there are, and it can extend them by that much, it will go ahead and do so. But if there are not any extendable DB spaces, it will go ahead and add an entry from the storage pool. So it's a super easy syntax now if we need to grow a DB space. Now, we've been adding chunks from the storage pool. We can actually go ahead and create a whole DB space from a storage pool. The syntax is almost the same. Create DB space from storage pool. We give it the name of our new DB space and how big we want it. Here we've created a DB space, data DBS4, and it was allocated from an entry in the storage pool. Again, we're using offsets because Informix found that there was enough room in the existing file that it could just go ahead and say, oh, it's got a little bit of space here I can use to satisfy this request. So real easy syntax now just to create a DB space. We can do more than just a regular DB space, but we can use a similar syntax for creating blob spaces, SB spaces, temporary spaces, and temporary SB spaces. So we've been talking about pulling stuff out of the storage pool or using stuff that's in the storage pool to create new chunks and DB spaces. We can also put entries back into the storage pool if we no longer need them. So here we're dropping a chunk. Instead of just dropping the chunk and being done with it, we're saying drop the chunk and put it back in the storage pool. So again, similar syntax that you might be used to with onspaces -d. We give it the DB space name, the path to the file, and the offset. This will do two things. It will go ahead and drop the chunk from the DB space, and then it'll put either a new entry or update an entry in the storage pool table so it can be allocated later on to other things. Something to bear in mind here is that we can do this even if that chunk was not originally assigned from the storage pool. And we can also do something very similar, and we can drop an entire DB space along with all of its chunks, assuming they're empty, and we'll place them all those resources back into the storage pool, and then that can be given out to other DB spaces, or if we need to expand any DB spaces. The message that appears is very similar to what we'd see if we did a onspaces -d to drop a DB space. Now, again, just like with dropping a chunk to the storage pool, that DB space would not necessarily need to have been allocated in the first place from the storage pool. So that's all great and everything, except what gets confusing is if we created some of those chunks and we named them handy names to indicate the DB space they were attached to, those get put back into the storage pool along with the names that were originally assigned, of course. So here's a case where I dropped a DB space back to the storage pool. That DB space was data DBS3. One of the files representing one of the chunks, I'd named to data DBS3. Now, what could happen is I could add a new chunk to data DBS4. From the storage pool, and I'd have this name attached to data DBS4, and that's going to be really confusing. So be very careful if you're returning stuff to the storage pool that's got very specific names. That's why I called all of these files just a general name, like chunk file 1 and 2. If you do have multiple chunks allocated from the same resource, like we had earlier, where we got that file was being used with offsets. If I drop all of those and return them to the storage pool, they will be combined as a single entry. So if I had a 6 gig file with 3 chunks of 2 gig each, and I return all those to the storage pool, instead of having 3 separate entries of 2 gig, will have 1 entry of 6 gig. You can still, even if you're using a storage pool, you can still drop DBSpaces and individual chunks with onspaces-d. Thing to remember though is if you go ahead and do that and they were originally allocated from the storage pool, you'll still have an entry in the storage pool for that. So thinking this through, if you've got a DB space with some cooked files, you go ahead and drop that DB space, you might be tempted just to then go ahead and delete the underlying files. Because I don't need these anymore, I'll just free up space on the file system. That's great, but if the entry remains in the storage pool and there's an attempt to use that to add more chunks, you'll get a failure saying, okay, I can't allocate from this resource. If you're going to go ahead and do that, it's a good idea just to delete the storage pool entry, just so everything stays in sync and you're not going to run into those errors. And which entries will be used when you allocate a space? I mentioned earlier, there's a priority for each entry in the storage pool. It goes from 1 through 3, 1 being the highest. So there is some logic that goes on in terms of trying to identify which entry in the storage pool is a good match for the request that's been made. I couldn't get a good handle on it though, and I saw different results whether I try to expand the space with the modify space expand versus if I try to just create a chunk from the storage pool. The entries that would choose from the storage pool were different. So I'm not really too sure what the logic is, all the rules are behind that. So I mentioned earlier, you can also add a directory to the storage pool. This is a handy feature, especially if you've exhausted all your storage pool entries, but you still want to, you don't want anything to fail because it can't expand. You can just put a directory name in the storage pool. These two values are 0, and then you still specify the size or the minimum size of any chunk to create from this. Now what happens if you go ahead and say, okay, create an entry from the storage pool, and this is the only one left, Informix will automatically create a file in this name directory and allocate it to your DB space as a new chunk. They're automatically marked as extendable, and it follows a naming convention with the instance name followed by the DB space name followed by a P and then a sequential number. So in this example, I've gone ahead, I've added 3 chunks, all of which were created automatically for me in the directory that I created. So that's great. But thing to bear in mind, because of this rigid naming standard and that we've got a DB space name in there, we run into that same problem. If we decide to return all of these to the storage pool, then something with data DBS5 might be used to create a data DBS6. That's going to get really kind of confusing. So earlier on, we talked about SP threshold as a way to have Informix automatically maintain a certain amount of free space in all our DB spaces. So that applies also if we're using storage pool. Informix will try and go ahead and extend any spaces, and if it can't, it'll allocate from the storage pool. Now, if we've set something like, okay, I want all spaces to have 10% free in them, and we're using the storage pool, we got to be careful now because we may have DB spaces that we know are static. They're not going to grow. So we don't want them Informix automatically adding additional chunks to it to maintain a certain amount of free space. The log DBS is a good example. Normally that's, you set it to a certain size, you fill it up with all your logical logs. You're not going to want to stretch it out until you want to add more logs. So you can have particular DB spaces excluded from that automatic add. And you do that again with modify space SP sizes. You give it the DBSpace name, and then you tell it that the size is 0 and the minimum size of any space, any chunk created for this DBSpace is 0. And what you'll see as soon as you do that, that under onstat-d, the A will disappear from the flags. The A simply means it is available to be expanded automatically. But here you can see I've disabled the automatic expansion from the phys-dbs and the log-dbs. So as I said, we'll see for using SP threshold, we'll automatically allocate extend spaces and then allocate from the storage pool. I have found that when that job runs, and it's that same job, that mon low storage, we'll only ever allocate a single chunk to a DBSpace, even if we really need more to meet SP threshold. And you may have seen this message before in the Informix log, especially when you start up Informix, saying a storage pool's out of space. You should enable automatic chunk creation. That's great and everything. But then you look at all your DBSpaces and you're like, okay, I got free space in all my DBSpaces. If you start seeing this message, chances are that you've set SP threshold to a value greater than 0. And when Informix starts up, it checks all those DBSpaces and say, okay, do I need to expand any of these? And you may have some, perhaps like log DBS, that there might be like 99% used. Informix saying, oh, I need to grow this guy because my SP threshold is greater than 0. And it tries to expand, it goes, oh, no extendable spaces, nothing in the storage pool, and generates this message. So if you're getting this, you should probably go through and mark all of your DBSpaces as not extendable, at least the ones that you never want to expand. So we've used entries from the storage pool to create chunks. There's some commands here we can use to manage the entries in that storage pool. Storage pool delete, storage pool modify, like if we want to change the priority of a particular entry, and storage pool purge. Something to remember is if we do delete entries from the storage pool, or if we purge everything, it does not detach any chunks that were assigned from that storage pool from the DBSpace, which is good. We wouldn't want that. But neither does it remove any of the underlying resources, even if they're not used. One of the issues, though, is if we've got it, we allocated some from the storage pool, we used a chunk, we used like 5 gig from a chunk, from a file, and it's a 10 gig file. We're left with 5 gig there, and we've deleted that entry from the storage pool, but there's 5 gig that will never be used unless we then decide to start using offsets. And now it's not being managed and tracked by the storage pool, so it does get kind of confusing. My last bit here, I wanted to say, if you need to run that monlow storage task manually, just to expand the space, you can do so by updating the PH task table. And you just update any column there, and it will just go ahead and kick off that job. I was going to do a demo. I think we're kind of low on time here. I'm going to skip that, and we'll be opening up to questions in just a minute. So XDB systems, we provide remote DBA support and remote monitoring, a team of consultants. Lately, we've been doing a lot of upgrades and migrations. And our remote DBA services has been very popular. Okay, I'm going to go to questions. I see there's a couple in the chat here. Mark, you said slide 27. Okay. 5 chunks that now have free space that can't be used. All the way back to 27. Is this the slide you meant, Mark? You've got 5 chunks that now have free space that can't be used. I got the right slide here. This is just saying that it tried to extend chunks, but we couldn't because we were running an archive. We're not wasting any space here. It's just we try to extend it, but we can't. Probably end up with errors in the application. So yeah, we're not wasting any space. We're just not getting, we're not able to extend them automatically.
I just unmuted Mark in case he wants to follow up with this one.
I'm kind of shy, so I'll try my best. I thought this was, in an earlier example, you talked about a chunk not being able to be extended, and you did a quick example of there was a slice at the end, and then you had to.
That's the previous slide, yeah.
Oh, yeah. So that doesn't happen when it fails because of archive.
Correct. It's a good question. In this case, we tried to stretch it out, and we were happily stretching out, and we hit a file system limit, and Informix gets the thing like, okay, this operation failed. In this case, it didn't even try. It tried to, it said, okay, I'm going to do this. Oh, my root DBS is being backed up. I just can't go ahead and do this.
Okay, makes sense.
So you shouldn't be left with anything unused.
Okay, thank you.
Thanks for that. Whoops.
That was the only question that I see in there. Or if anybody else has any questions for Mike, just go ahead and enter it in the chat.
Thank you. I'm sorry I didn't get time to do the demo here. We'd have just been expanding some spaces and adding space from a storage pool. But I think the slides here will show you exactly the same kind of thing. It was just a real life example. Okay then. Well, thank you everybody. This was good. Reach out to me if you got any questions. My information's right here. And thank you for tuning in.
Thank you, Mike.
Thanks.